to Chanan Academy. In today's class, we're going to talk about sequence and series. So first we'll start with sequence. Now, what is a sequence? A sequence is an ordered list of numbers that follows a particular pattern or rule. That number one, it is an ordered list. The list is ordered. Ordered list. Number two, that it follows a particular pattern or rule. There must be an order and it must follow a pattern or a rule. So let me give an example. For example, we can have 2, 4, 6, 8. Now, you see this, it follows a pattern and there is a rule. The rule is you add 2 to each number to get the next number. So if we add 2 to 4, we get 6. If we add 2 to 6, we have 8. All right. Also, we can also have 3, 6, 12, 24. Now, if you see this also, it follows a pattern. Can you guess the pattern? All right. So if you have 3, what you need to do with 3, you multiply by 2, you get 6. If you have 6, multiply by 2, you get 12. If you multiply 12 by 2, you get 24. So that's the pattern that it is following, and it is the rule that governs this particular sequence. All right. So let's talk about series. What is series? What is a series? A series is obtained when the terms of a sequence, a particular sequence, are added together. Sequence are added. So we have 2, 4, 6, 8. This is a sequence. Now we want to get the series. For us to be able to get the series, it becomes 2 plus 4 plus 6 plus 8. So this is a series and this is a sequence. So let's talk about a term. What is a term? Now, each number of a sequence is called a term. Each number of a sequence is called a term. So if we have, like the previous example, we have 2, 4, 6, 8. Now, 2 is called the first term, while 4 is called the second term, 6 is called the third term, then 8 is called the fourth term. This sequence keeps going. So there's a possibility that there's an end term that we do not know about. So the end term is going to be called the end term. Types of sequence. Majorly, we have 2 types of sequence. The first one is called the arithmetic sequence. Sequence or progression. AP. The second one is called the geometric sequence or progression. GP. The arithmetic progression. The arithmetic progression is a type of sequence in which the difference between the consecutive terms is constant. So let's give an example. If we have 2, 5, 8, 11, 14. This is called the first term, and this is the second term, the third, fourth, and fifth. Okay, if we look at the difference between the first and the second term, we are going to have The first term is 1, the second term is 5. So we have 5 minus 2. The difference is 3. Let's look at the difference between the third term and the second term. That will be 8 minus 5. The difference is also 3. If we look at the same fourth term and the third term, it's going to be 11 minus 8, and this will be 3. Let's look at the fifth and the fourth. So the fifth and the fourth is 14 minus 11, that will be 3. So you see that the common difference between each of them is constant. This 3 is called common difference and is represented as D. Let us assume that 2 is A. Therefore, 5 will become A plus the common difference, which is D. Also, 8 becomes A plus 2D, which means we multiply the common difference twice. And then 11 will become A plus 3D. Then 14 will become A plus 4D. So let's try if it is true. So if A is, let's try for the fifth term, if it is true. If A is 2 and D, and then we have plus 4, the difference is 3. So therefore we have 2 plus 4 multiplied by 3, we have 12. So 2 plus 12 is 14. So you can see that this is true. So therefore we can agree that for us to find the n term, suppose this sequence keeps going, for us to find the n term that we do not know, we can agree that the n term is going to be A plus n minus 1 D. Now don't be confused by this n minus 1. Let me re-explain that for you. So if the fifth term is A plus 4D, now look at it, it is called the fifth term. So let's say it is called T5. So then we have T5, which is the T is term, the 5 is the fifth term. So then we have equal to A. Let us separate the 4 and the D. So we're going to have 4 multiplied by D. Is that correct? Okay, so we are going to then have A plus, don't forget it is fifth term. So, but it's having 4 at this point. So it simply means we can have 5 minus 1 D. T5. T5 will now be equal to A plus 5 minus 1, all bracket close, multiplied by D. So if we replace the 5 with the n term, it becomes Cn equal to A plus n minus 1 D. Now this is the formula for arithmetic progression. Now take note, don't forget, the Tn is called the n term. Now the A is known as the first term, while the D is the common difference. Now let us work some example. Alright, so we're asked to find the fifth term of the sequence 12, 17, and 22. So solution. So we first of all find the common difference. We already know that A is the first term, which is 12. Don't forget that the formula is the n term is equal to the first term plus the term you're looking for, that's the n term, minus 1 bracket D. Okay, so we already know that A is 12. So let's find the common difference. That will be the second term minus the first. So we have 17 minus 12, and that is 5. Let's say the third term minus the second term, let's be sure. So that will be 22 minus 17. And this is also equal to 5. So the common difference is 5. So we have the fifth term will be equal to 12 plus 5 minus 1. The common difference is 5. So this will be equal to 12 plus 4 multiplied by 5. We are going to have 12 plus 4 multiplied by 5 is 20, so we have 20. And 12 plus 5 is 32. So the fifth term, that's T5, is equal to 32. Alright, sum of an AP. Suppose we are given a sequence, say 1, 2, 3, 4, and 5. And we are asked to find the sum of this sequence. So we can have 1 plus 2 plus 3 plus 4 plus 5. That will be equal to 15. But however, there is a short formula which I'm going to give in this class. It is given as Sn n over 2 brackets 2a plus n minus 1 d. Now take note, Sn is known as sum of the n term. N is the n term, a is the first term, and d is the common difference. Alright, if we try to use the formula to actually look for the sum of the 5 term that was given up, let us check and see. So we become S of 5 equal to, so the n is the 5, so we have 5 over 2 bracket a is 1 plus 5 minus 1 is 4, and the common difference is 1. Okay, so we are going to have 5 over 2 all in brackets. 2 multiplied by 1 is 2 plus 4 multiplied by 1 is 4. So then we have 5 over 2. This will be 6. And if we open the bracket, we are going to have 30 over 2. Now 30 divided by 2 is 15. So the x5, the sum of the 5 term is going to be 15. So see, this formula is what is used whenever you are asked to find the sum of an AP. Alright, so this is the question. The question says, insert 3 arithmetic mean between 4 and 20. Okay, so solution. So this means we are going to have 4. The first number we are going to insert, the second, the third, and then we have 20. So how many terms do we have here? So we have the first term, the second term, the third term, the fourth term, and then the fifth term. For us to be able to look for the second, third, and fourth term, we need to know the common difference. And for us to find the common difference, we already know the formula for and the arithmetic mean, which is T of n equal to the first term plus the term minus 1, and then the common difference. Okay, so in this case, we have 5 terms. So it's going to be T of 5 at the fifth term equal to, first term is 4, so we have 4 plus n is 5 minus 1 d. So the T5 means the value for the fifth term. So what's the value for the fifth term? From the question, we know the value from the fifth term is 20. So we replace that with 20. So we're going to have 20. 20 is equal to 4 plus, now 5 minus 1 multiplied by d, we are going to have 4d. From this point, to take 4 to this other end, so we are going to have 20 minus 4 equal to 4d. So 20 minus 4, we are going to have 16 equal to 4d. So for us to find the d, we divide both sides by 4. So divide this by 4, this by 4. 4 into 4 is 1, 4 into 16 is 4, and therefore the common difference is 4. So we can go back up. So 4 plus 4, we have 8, and then we add 4 again, we are going to have 12. If we add 4 again, we are going to have 16. If we add 4, we are going to have 20. So this is our answer. The three numbers that are missing are 8, 12, and 16. Thank you. So let's take another one. Alright, so we are asked to find the 25th term of this sequence. Okay, so let's bring out the formula. So we have T of n equal to A plus n minus 1 and the common difference. We're looking for the T25. The first term, which is A, is 5. So put that as 5. So what is the common difference? So let's find the common difference. The common difference is usually the second term subtracting the first term. So we have 9 minus 5, and this is equal to 4. Also, the third term minus the second term, let's be sure. So we have 13 minus 9, and that is equal to 4. So the common difference, which is D, is equal to 4. So we have plus 25 minus 1, 4. Therefore, the T25 is equal to 5 plus 24 multiplied 4. So then we have 5 plus, so 24 multiplied by 4, that will give us 96. Therefore, so now 5 plus 96, we have 101. So our 25th term will be 101. Geometric progression. A geometric progression is a sequence in which each term is obtained by multiplying the previous term by a constant ratio. So each term can be obtained, or the next term can be obtained by multiplying the previous one by a constant ratio. Let's give an example. Let's say we have a 2, 6, 18, 54. Alright, so this is the first term, the second term, and this is the third, and this is the fourth. So how did we get the third term? So what we need to do is to look at the ratio of the second term and the first term. So the ratio of the first and the second term is 6 over 2, which is equal to 3. If you multiply 3 by 6, you're going to get 18. So let's also see the ratio of the third term and the second term. So the third term is 18, the second term is 6, and this is also 3. Let's see the fourth term and the third term. So the fourth term over the third term, this is going to give us 54 over 18, and this is still going to give us 3. Now you see, for us to get the second term, which is 6, we multiply by this ratio 3. 3 multiplied by 2 will get 6. For us to get 18, which is the third term, we multiply the second term by the ratio, which is 3, and we get 18. So the same thing we'll do for us to get the fourth term. Now take note, these 3 are called the common ratio, and it is represented as R. Alright, so let's try to explain the example properly. So we have a 2, 6, 18, and 54. And we said that this is the first term, the second, third, and the fourth term. In this sequence, the common ratio, which is R, is equal to 3. So from this place, we can see that the sequence can be written as 2, bracket 2 multiplied by 3, bracket again 2 multiplied by 3, multiplied by 3, and then 2 multiplied by 3, multiplied by 3, multiplied by. Now, if we represent the first term 2 to be A, and then the common ratio, which is 3, to be R, so we can rewrite it as A is equal to 2 multiplied by 3. The 2 is A, so we say A, and the arrow is 3, so we say AR. Then this 3 multiplied by 3 can be expressed as 3 raised to the power of 2. 3 raised to the power of 2, so we are going to have A raised to the power of 2, and this can be expressed as 3 raised to the power of 3. So we have A raised to the power of arrow 3. Now, look at it very well. This is the first term, this is the second term, this is the third, and this is the fourth. So this means that if we are looking for the C of 4, which is the fourth term, we can say it is equal to A arrow raised to the power of 4 minus 1, because it's going to give us A arrow raised to the power of 3. Therefore, if we want to find the n term, it can then be written as A arrow raised to the power of n minus 1. So this is the formula for a GP, geometric progression, where n is the n term, A is the first term, and arrow is the ratio. Alright, let us take one example. Alright, the question is asking us to find the common ratio in the sequence. So the sequence is 4, 12, 36, 108. So this is the first term, the second, third, and fourth. So for us to find the ratio, we'll divide the second over the first. It's supposed to be equal to the third over the second, and also supposed to be equal to the fourth over the third term. Alright, so what's the first term? The first term is 4, and the second term is 12. So we have 12 over 4, which is equal to 3. So the third term is 36, 36 over 12, which is also equal to 3. The fourth term is 108 over 36, which is also 3. So the common ratio is 3. Alright, so that's the answer. The common ratio is 3. Sum of a geometric progression, GP. Suppose we are given a geometric progression where A is the first term and arrow is the common ratio. Then the sequence is going to be A arrow square, A arrow n minus 1. So this is how the sequence is going to be. So if we're asked to sum this sequence, the summation is going to be, summation of the n term is going to be A plus A arrow plus A arrow square plus A arrow n minus 1. Let's call this one equation 1. If we decide to multiply the right hand side and the left hand side by the ratio arrow, so we are going to have on the left hand side, we're going to have a arrow n equal A arrow square plus A arrow to power 3 plus A arrow n minus 1 plus A arrow n. Let us call this equation 2. So if we decide to subtract equation 2 from equation 1, we are going to have on the left hand side n minus arrow n equal. Now on the right hand side, if we decide to subtract equation 2 from 1, you will realize that this is going to cancel at this, and this is going to cancel at this. This is going to do the same thing for every other thing. Now the only two terms we are going to be left with is just A and A arrow raised to the power of n. So that is going to give us A minus A arrow raised to the power of n. From this, we can decide to factor out. To factor out the left hand side, we are going to have Sn bracket 1 minus arrow equal. So we'll factor out A on the right hand side, we're going to have A bracket 1 minus arrow raised to the power of n. So let's divide both sides by 1 minus arrow. So this is going to cancel out this. So we are going to have Sn equal a bracket 1 minus r raised to power n all over 1 minus r. So this is a formula that is used to solve for the sum of the n term of a geometric progression. Whenever you're asked to find the sum of a geometric progression, this is the formula. Alright, so let's take an example to explain this. Find the sum of the first 5 terms of the sequence. Alright, so let's put down the formula. Sn is equal to a bracket 1 minus n all over 1 minus r. A is equal to 2, which is the first term. In our ratio, r is going to be equal to the second term divided by the first term, which is equal to the second term is 6, the first term is 2, and this is going to be 3. So our ratio is 3, and the first 5 term n is going to be 5. So if we plug in our value, we are going to have Sn equal to 2, 1 minus 3 raised to the power of 5 all over 1 minus 3. And this is going to give us 2 bracket 1 minus 243 all in bracket over 1 minus 3. And this is going to be equal to 2 all over 2 all over minus 2. And this is going to be equal to, if you open the bracket, you are going to have minus 484 all over minus 2. If you divide this, if minus 2 go into minus 2, you have 1. Minus 2 into this, you are going to have 242. So our final answer, Sn, is equal to 242. So this is the sum of the first 5 times of the geometry sequence given above. Alright, so let's take one more example. Alright, so we're asked to find the sum of the first 8 times of the geometrical progression. This. First, we need to state the formula. Sn equal to a bracket 1 minus r raised to the power of n all over 1 minus r. From the question, our first term a is equal to 1, and then the ratio r is going to be equal to the second term over the first term. Since it is a geometric progression, so we are going to have equal to the second term is 2, and the first term is 1, so the ratio r is 2. And the term we are looking for, n, is equal to the first 8 terms, so n is equal to 8. So let's substitute the value into the formula. So the formula S of 8, the sum of the first 8 terms is going to be equal to, the first term is 1 minus, the ratio is 2 raised to the power of 8 all in brackets over 1 minus 2. And this is going to be equal to, Sn is equal to 1 minus 2 raised to the power of 8 is 256. And this 1 minus 2 is going to be minus 1. So this is equal to 1 in bracket 1 minus 255 all over minus 1. And if you open that bracket, you're going to have minus 255 over minus 1. Therefore, the sum of the first 8 terms is equal to 255, because the negative is going to cancel out the negative. So this is our answer. Sum to infinity of a geometric progression. Now, a geometric progression whose common ratio is between 1, -1, and +1. That is, between 1 and +1. So the ratio is between this. For example, if we have a sequence 8, 4, 2, 1. Now, the common ratio is going to be arrow, second term over the first term, which is going to give us 4 over 8, and this is going to be 1 over 2. Now, 1 over 2 is between -1 and 1. So, sum to infinity of a geometric progression. A geometric progression whose common ratio is between -1 and 1 has a sum which approaches a finite value as the n term approaches infinity. And it is given as S the sum of the infinity is equal to the first term over 1 minus the ratio, the common ratio. Now, let's take for example, we have 8, 4, 2, 1. Now, the common ratio of this sequence is going to be, common ratio arrow is going to be the second term divided by the first term, which is also equal to the third term divided by the second term. So, and this is going to be, so the second term divided by the first term is going to be 4 divided by 8, and this is going to be 1 over 2. Now, 1 over 2 is greater than minus 1, but is less than 1. The sum of this type of sequence is the sum to infinity. Alright, so let's take an example to explain this. So the question says, find the sum to infinity of the following series. Now, because it has already been stated that it is sum to infinity, we are going to use this formula, the formula for sum to infinity. The sum to infinity equal to a over 1 minus the common ratio. So now our first term is the a is equal to 3. So the common ratio arrow is going to be 2 divided by 3. So this is the common ratio. And if we substitute into the value, we have 3 over 1 minus 2 over 3. Now we're going to have sum to infinity equal to 3 over 1 minus 2 over 3 is going to give us 1 over 3. 1 over 3. So this is then equal to, so we are going to have 3 multiplied by 3, which is going to give us 9. So the sum to infinity is equal to 9. This is our answer. So let's take one more example. Alright, so we're asked to find the sum to infinity of this sequence. Alright, so we know already that the formula is giving us the sum to infinity is equal to a over 1 minus arrow. So our a, which is the first term, is 1. And our common ratio arrow is going to be the second term divided by the first term. So second term is 1 over 3 divided by 1, which is the same thing as 1 over 3. So that's the common ratio. So therefore we have the sum to infinity is going to be equal to 1 over 1 minus 1 over 3. And this is going to be 1 over 2 over 3. Therefore this is equal to 1 divided by 2 over 3, which is equal to 1 multiplied by 3 over 2. Therefore the sum of infinity is equal to 3 over 2. You can further break it down 1 whole number 1 over 2. So this is the answer. Thank you for watching the video till this time. See you in our next class. Don't forget to hit the like button, subscribe to our channel so you will not miss anytime we post any video like this. Thank you and bye for now.